Welcome to the stage, Eric.
Great, thank you so much. And first of all, just a big thank you to both Hani and Brett for the invitation to be here today. It's really fantastic to be able to talk to all of you today about what I believe really is the future of transportation. So I'm really excited to talk with all of you today about something that I think is really incredibly important to each of us, and that's time and how we spend it. So I want to start with a story from my own life. This is a map here of the Bay Area in San Francisco Bay Area where I live. My house is about here. In 2019, I worked at Uber in San Francisco at the top of the map here. And that's about a 50-kilometer or so drive. And I drive it nearly every day. This would take me about an hour and a half in the morning on a bad day. And then, of course, I had to drive home every day. And it took a long time. I think this is why in the dark days of the pandemic last year, as normal life ground to a halt and we all stopped moving, one of the most striking visuals to me was just the complete absence of something that I had just accepted as a part of daily life, and that's traffic. But as life has begun to return to normal, some in places, more places than others, traffic gets returned. And in some places, it's even exceeding pre-pandemic levels. Personally, I don't look forward to spending several hours of my life each day calmly sitting in a traffic jam going forward. And when you stop to think about it, it's really amazing what we're willing to tolerate. And it's not just me. If you add up the numbers, San Francisco commuters alone spend over 360 million hours each year sitting in traffic. That number skyrockets to 4.6 billion hours wasted each year if we look at the top 15 US cities. And now more than ever, I don't think of those as wasted hours. I think of them as missed hours. It's not time that you're at home with your family. It's not time with your friends or time at work even. And really the question is, how do we end up here and what can we do to fix it? So I think transportation moves in giant leaps. The steam engine was faster and more efficient than anything before it. The automobile brought individual, affordable travel to the masses, and the jet engine connected us all around the globe. These innovations were embraced by nearly every industry, transforming them. They made us more efficient, they reshaped their cities, reshaped our jobs, and even our lives. But I think these big innovations started to slow, and things really started to get worse. Quickly, the open road became the gridlocked highway. And transit hubs like train stations and airports became overcrowded, tedious, and frankly, to be avoided in a lot of cases. And I think the solution to this isn't just building more at this scale with demand. The costs have skyrocketed. In many places, there isn't even room for more expensive roads. And beyond the simple economics, there are environmental costs too. Transportation is the largest sector when it comes to emissions, and passenger cars, they're a big part of it. So we think there's a solution to this, and it involves learning from cities themselves, noticing that towns and villages became the metropolitan centers of life and commerce by building not just out, but up, taking advantage of the third dimension. And now we need to move travel in and around our cities from 2 dimensions to 3. Move people up and over the congestion and without harmful emissions. So I know what everyone's thinking. The sci-fi promise of flying cars has been around forever. And as Chuck just mentioned, it's never saw the light of day and never really made it beyond illustration. Helicopters have been our best attempt. Services with helicopters sprung up in the 50s and 60s, and even now in some places, but they've never scaled. They've never had that real impact of transforming cities. And it's not because helicopters don't work. They fly. They fly well in a lot of cases, but they're just not the right aircraft for the job. We've got too many points of failure. They're super loud. They can't integrate into everyday normal life. And they're just not practical. They're expensive to operate, and they're slow, limited by weather. So we asked ourselves a while ago, what would the right aircraft look like to actually do this mission? Well, it'd have to be safe. It's going to have to be quiet, and it's got to be practical, getting people to where they need to be quickly, easily, and efficiently. So a little over 10 years ago, we had the insight that an electric powertrain using electric motors instead of traditional combustion engines could be the answer to solving this problem. In fact, that's how Joby started. And this is not a flying truck. This is actually a wing that Joe Ben, our CEO, and his then very small team designed for NASA back in 2012. It was intended to test efficiency improvements and safety of multiple electric motors for flight. And really, it was the foundation of the work on batteries, motors, controls, and aerodynamic analysis necessary to make practical electric flight a reality. So in 2014, these insights began to coalesce into the design that we've been working on ever since. Not so much the flying car of popular science, but instead an air taxi, an aircraft that could move people safely, quickly, and at a wide scale. So we assembled and flew a quarter scale version of this aircraft back in 2015. In 2017, we flew this full-size prototype here and gathered data across hundreds of test flights. And today I'm delighted to share a picture of our production aircraft. Here it is. This is all electric, vertical takeoff and landing, 4 passengers, optimized for aerial ride sharing. So think Tesla meets Uber in the sky. Through over 1,000 test flights, this is the largest, most performant electric VTOL aircraft that's ever been flown. And so you can see one of our test flights at our electric flight base. The aircraft there took off vertically, transitioned out to horizontal flight. Here it's cruising in a very low noise cruise mode and flying a pattern. And then we'll see it in a second, it's going to convert back into to vertical takeoff mode and then land vertically, just like on a point, just like a helicopter kind of. And I've seen more eVTOL aircraft fly than just about anyone, and have to say it just never gets old seeing this aircraft flying through the sky. So let's take a closer look at the Joby aircraft. As we just saw flying in that video, it has 6 propellers that can rotate from pointing up to pointing forward, so it can take off and land vertically like a helicopter, while flying incredibly efficiently and quietly like an airplane. This is a vehicle that can make the promise of 3D travel, not science fiction, but a reality. So we started out with safety. So number 1 priority, it's our North Star. Helicopters have more than 50 single points of failure, and we aimed for 0. We applied our learnings from that wing that you saw earlier to a unique 6 propeller layout. Individual stations can fail and we can still operate normally, but even that's remote because each of the subsystems is also redundant. It's the level of safety associated with large commercial planes, but brought through electric propulsion to these smaller aircraft. And we've made some pretty significant innovations around noise. Sometimes folks think that just by building an electric aircraft, it's going to be quiet, but that's really not true. It's not only about reducing the engine noise, but addressing the propeller noise too. That means optimizing the size of propellers, the speed at which we're spinning them, and even the geometry of the blades themselves. We spent a lot of time making sure that we got this right, and we're pretty pleased with the results. To put it into context, here's a range of noise on a decibel log scale. From the peaceful noise of rustling leaves, maybe 20 decibels, to the roar of a jet engine at 150 decibels. Sounds like thunder or helicopters disrupt daily life. Our aircraft is at its loudest about 65 dB, quieter than a vehicle on the highway. And in overflight, it's just 40 dB. That's equivalent to noise in a library. This noise profile is so important because it's what allows us to operate at high volume and high density in and around residential areas. So we've released several videos in the last few months to try and let people experience this for themselves. You kind of have to see it to really understand it, or maybe hear it to really understand it. In one of them, we compared a parade of conventional airplanes flying overhead with our aircraft using a calibrated microphone. So grab a good pair of headphones, go to our YouTube channel and listen to it yourself. It's pretty cool. So building an aircraft that's practical meant focusing on things that can make the service both useful and surprisingly affordable. At the center of this is the powertrain. With every iteration of our aircraft, just like the pioneers of electric ground vehicles, we discovered that off-the-shelf components just weren't cutting it. The batteries, motors, and other components necessary for flight weren't up to our standards, so we designed our own. We engineer our own battery packs, allowing for greater energy density at the pack level and our own unique safety requirements. We 3D print pieces of our motor assembly out of titanium to maximize our torque density. And we develop custom processes for carbon fiber components to get the right performance without the high labor costs. In the end, we're proud of our technical accomplishments, but even more so that they deliver what really matters to passengers. A passenger capacity that's sufficient for a family, 150-mile range in a single charge, letting us do both trips inside cities, but also trips connecting cities to the suburbs, as well as cities to other cities. And a 200-mile-per-hour cruise speed. That's the speed in a straight line or relatively straight line travel. So we get people to where they want to go faster. And as you saw, capable of vertical takeoff and landing like a helicopter, meaning that we can operate them not just out of airports, but at helipads and new sites ever closer to where people really want to go. And piloted by a professional pilot on board, meaning no changes in the way air traffic control and flight planning are done. We give passengers the same peace of mind that they have on a commercial airline flight. We've achieved our goals in each of these categories, but we also wanted to ensure that whatever we build helps in our own way to accelerate the shift to more and more sustainable transportation. We want every trip we shift from a combustion vehicle on the ground to an electric vehicle in the air to have an impact on transportation emissions. Of course, overall, this is about utility, saving time, getting you from point A to point B. But it's really worth pausing on what the experience will be like when we launch in 2024. I think that soaring over the landscape gives us a new perspective on and a new appreciation for the world around us. It's an experience that our passengers will anticipate, they'll enjoy, and we hope they'll really love. So think back to that same sense of wonder you had when you first got on a commercial airline to go somewhere you'd never been before. While certifying a new aircraft, scaling production, rolling out a new transportation service, it's a pretty tall order. We're not doing it alone. We partner with Toyota, who's assisting us on production, taking high quality, high volume manufacturing that they've perfected in the automotive space to help us design and scale our production system. Our partners in real estate will allow us to take advantage of existing infrastructure and provision new skyports both quickly and cost effectively. We've got fantastic government partners in the US Air Force through Agility Prime, as well as NASA, where we're incredibly excited to be the first company to have done test flights under the NASA national campaign just a month or two ago. And Uber is a keystone partner for both demand generation and seamlessly integrated first and last mile transportation to and from your flight. From the very beginning, Joby flights will be available on the Uber application, and we'll use Uber cars to get you to and from the skyport. So in the end, we're not just creating a plane, we're really building a service. We don't believe in a Jetsons future where everyone has one of these parked in the driveway or perched on their roofs. We don't expect you'll train people to be a pilot with us. We want to make flying with us as simple today as booking a car. So how would this work? Well, you'll open up the Joby app on your phone, or you'll choose the Joby option in one of our partner apps like Uber. So you enter your final destination, you confirm the trip, and the tech in the background will just take care of the rest. Our network will synthesize a full multimodal itinerary and dispatch a rideshare car to pick you up to the first leg of your trip and take you to the optimal skyport. At the skyport, you'll be directed to board a Joby aircraft with up to 3 other riders who have been matched into the same flight just in time by our network. Then you'll fly to the destination skyport at up to 200 miles an hour, like I mentioned. As you exit the aircraft at the destination, our network will have dispatched a second rideshare car to meet you just as you leave the terminal and take you that last mile to exactly where you want to go. When I led Elevate at Uber, we focused on understanding just how an aerial ride-sharing service like I just described would work. We realized that the seamless connection of ground and air modes, which we call true multimodality, was critical. And so we built and launched Ubercopter in New York City as a proof of concept of this idea. We operated Copter, which is the world's first iteration of an end-to-end multimodal aerial ride-sharing service, for nearly a year to prove it out. Completed over 1,000 multimodal trips. Both the technology and the learnings that powered that work with Copter, as well as the IP that was created behind it, was acquired by Joby as part of the Elevate deal. So at Joby, we're continuing this vision. The suite of technologies we built to power Ubercopter form the foundation of the service that we're building. Whether it's integration into rider apps, pilot apps, heliport and operation apps, or the backbone that weaves this all together, we're building it. Our technology will seamlessly integrate first and last mile ride sharing, whether trips are booked through a partner app like Uber or through the Joby app. Our service will be a true point-to-point solution for traveling across our cities in this delightful new way. And we're building this service on a foundation of data. Using the methods we developed at Elevate and are continuing to refine and build out here at Joby, we can deeply understand movement in each city that we're interested in. And from this data, we can identify key locations to build infrastructure to maximize the throughput of our network. as well as design routes that work within existing air traffic constraints and can grow and scale over time. As we build out these networks, we'll be able to serve the most riders with the fewest skyports. So what would trips on our service look like after we certify our aircraft in 2023 and launch it in 2024? Here are some of the ways we can improve the way you move in a market like Los Angeles. Let's say you need to get from LAX to downtown LA. We can get you there in just 8 minutes versus more than 45 minutes driving for just $40. We can get you from breakfast in Santa Monica to a meeting in Burbank in 12 minutes versus 50 minutes driving on a good day for $50. And let's say you want to get from Hollywood to Palm Springs. There's a ton of traffic on the roads because it is LA. What can that trip? We can do that trip too. In just 50 minutes versus 2.5 hours on the ground, all for $120, cheaper than the cost of a car service. So at scale, the sum total of these trips can, we believe, deliver tremendous value to cities and to customers. Well, we also build a pretty valuable business. With 22 skyports in a city like LA, that means 300 highly utilized aircraft generating more than $500 million in recurring service revenue. But more importantly, saving people nearly 1 million hours of time per year that they'd otherwise be missing sitting in traffic. And removing 13 million car trips from the city's roads and saving 61,000 tons of CO2. And LA isn't unique. The problems of population density, urban sprawl, the failure of existing infrastructure, and of course, the environmental impacts of it are all global problems. Our goal is to save 1 billion people an hour a day. What would you do with an hour? Maybe it's catching the flight you would have otherwise missed, making it to the school play, seeing your newborn child, getting home in time for dinner. Well, that's what motivates us every day. So follow our progress as we shift transportation from 2 dimensions into 3 dimensions, make a contribution to removing congestion, lowering environmental footprint of transportation, and at its core, saving you time. Thank you very much.